Hello and welcome back. So we have understood a little bit about Pandas DataFrames, and let us try to understand little more what we can do with Pandas DataFrames. We can do visualization, we can do filtering, we can do many more things. Let us try to understand one after the one by one. So here I am trying to write some visualization code. When I say visualization code, internally the data frames are using matplotlib. So I have taken the data frame and tried to take the column quiz1 and then took the value counts. Let us see what is value counts. I hope you remember in the series object we have seen that value counts will give you the values and their counts, right? So there are 6 sixes and 5 sevens, 4 eights, 3 nines and 2 fives. That's the value count. And using value count you can do a bar chart. What is a bar chart? On a bar chart, on x-axis it takes the values 6, 7, 8, 9 and 5. And y-axis it takes the counts, and bar height is going to be the count. Let us try to execute the cell and try to understand one component at a time. So if you look at this chart, there is x-axis, there is y-axis. On x-axis I have kept score, on y-axis I have kept the number of students. So how did I got this graph? With this statement I have got this. So the data frame object of the column name and the value counts actually gave this kind of a data, and then the plot method internally calls the matplotlib's plot method, and there is a bar in the bar method in there, and then the rotation 0 actually tries to rotate the x-axis numbers to the correct position. Rather they will be in 90-degree position. If you take out this and execute, you see they are slant, right? When I kept it to 0, they actually became proper. Okay, and then the x label, PLT is the matplotlib's alias name, matplotlib's pyplots alias name, and x label is a method which actually assigns label to the x-axis. Y label is another method assigns label to the y-axis, and then y ticks is another important method which actually specifies the scale on the y-axis. So here I have taken np.arrange of 7. In NumPy we will understand that what it is, but at a high level if you want to understand, it created an array of 7 values from 0 to 6. Okay, so in the data set the counts are maximum count is 6. So I have created 7 values. So I have passed 7 values here. So this is kind of scale. So you can actually pass a list also there. So NumPy array or list can be passed to the ticks. It's actually the scale. Okay, so this is a bar chart, and when you look at this bar chart you see that you can understand that the y-axis is count and x-axis is the value. There are 6 values for 6, 5 values for 7, 4 values for 8. We have seen the data set, right? So on the second quiz also, if you want to do the visualization, here I used the NumPy array again, or I can actually use the list also. Why we are using NumPy array? Because on a big data set you may have to use a NumPy array, because you cannot actually type these numbers like this on a big data set, right? So there are three numbers, 3 nines are there in the data, 3 sevens are there, 2 eights are there, 2 fours are there, like that. We need to be able to understand and generate visualization. So if somebody gives you a graph, you should be able to look at the graph and understand the data, or you be able to generate the graph also. So that's where we have seen a little bit of visualization. So one more point in statistics we have understood was box whisker plot. I don't know whether you remember it or not. The interquartile range is a concept which explains you or which shows you the outliers statistically, whether a number is outlier or not. But using business knowledge you will decide whether the data point is really an outlier or not. But box whisker plot visually shows you the interquartile range. Why do you need visualization? When the data is huge, you should definitely need visualization. You cannot actually look at the numbers and decide or understand. So if you have to do a box whisker plot, there is a method called box plot in DataFrame. Internally, these methods are calling the matplotlib's visualization methods only, but the box plot on the DataFrame will give you box whisker plot for the columns we have passed. So I have passed quiz 1 and quiz 2. The student number is not numerical, so you cannot do box whisker plot for the categorical column. So I have passed the numerical columns quiz 1 and quiz 2 and did a box whisker plot. If you look at this plot at the 7, right, let me magnify this. 7 is the mean or median. If you try to sort the data in ascending order and try to see the middle number, you will get 7. On the first quiz and second quiz, both you will get the 7 is the median. That's the quartile 2. And 6 is the first quartile, 8 is the second quartile. And the values above 8 are kind of outliers, or below 6 are kind of outliers statistically. But in reality, if you see in that quiz, there are students who have got those marks. What is outlier means? Maybe somebody with a fat finger, they typed the wrong data. Right? Statistically, if you want to see, that's a wrong data. Or maybe a device is not working properly and trying to dump erroneous data into the server. Those kinds of things are called as outliers. Here, statistically it is showing that, but when you know the business, you can actually decide whether they are really outliers or not. And the second data set also, 7 is the median or the quartile 2, 5 is the quartile 1, and 9 is the quartile 2. So that's about that's all about the visualization. Thank you.